All right, guys, we're starting factoring by GCF. All right, so to factor, this is basically we are taking it backwards from where we've been. So where we've been is we've taken two factors and we multiplied them together to get a polynomial. We are now going to work from taking a polynomial and then breaking it down or simplifying it as much as possible. So we would call this probably, let's say, opposite of multiplying. So basically dividing at this point, because that's the opposite of multiplying. GCF, that means the greatest common factor. Hopefully we remember this from a class before now, but if not, this is your time. So greatest common factor. Prime means the number, there's no common factor other than itself and 1. So like the number 3, the only thing you can multiply together to get 3 would be 3 and 1. The number 5, the number of numbers you can multiply together to get 5, it's 5 and 1. 7, again, 7 and 1. So GCF, greatest common factor. So that's where we're really looking at what do we multiply together to get a number. So if we were to do 10, we could do 1 times 10, 2 times 5, and then we've got a prime number, because it's just 2 and 1, and a prime number. So our factors would be 1, 2, and 5, depending on what we're looking at. So if you had 10 and 20, and we want the greatest common factor, so from 10, we know we have 1 and 10, 2 and 5, right? So 1, 10, 2, and 5. For 20, I'm going to have 1 and 20, 2 and 10, 2 and 5. So that means I also have a 4 times 5, right? Because these go together, so that could give me a 4 as well. But if I'm looking at this list of numbers, this 10 and this 10 are going to be the greatest common factor between the 10 and the 20. So you're making a list of all the numbers that can multiply by something to make that number, and then picking the one that's the largest, the 2 numbers or 3 or 4 or 5 numbers that we're comparing have in common. All right, so factoring is like dividing or using distributive property backwards. So we're saying dividing because when you use distributive property, you're multiplying. So to find the GCF, otherwise known as greatest common factor, so those are all the numbers that we divide out of a number, so that when we multiply them together, they give us a number. So we're going to see what they all have in common, including numbers and variables. Variables is where many students get messed up, but we need to see what they have in common, and then we're going to remove what it is they have in common, and then whatever the leftovers are, so these are what I'm going to call leftovers, where it says show is left, and then check by redistributing what you removed. So this is what we did last week. So distributing all the way through, whether it be 2 binomials, a monomial, a binomial, or whatever. We'll see. All right. So for this example, I'm going to look at these 2 numbers. I have a 5 and a 3. So if I'm looking at 5, the only thing I can multiply to get 5 is 1 and 5. I'm looking at 3. The only thing I can multiply to get together 3 is 1 and 3. So if I look at 1 and 5, 1 and 3, what do they both have in common? A 1. There is no need to pull out a 1 ever, because remember, distributing the 1 all the way through gives us nothing but the same thing we had. So we just took care of our numbers. In theory, we looked at those. This does have an X. Does the second one have an X? It does. It has 2 of them. So remember, this is basically writing this. So 5 and 3 is the best we got. So numerically, we can pull out a 1. No need to write that really, because remember, multiplying by 1 does nothing but make it the same thing. So after looking at our numbers, we look at our X's. There's definitely an X here and an X here, so we're going to pull out an X. And so if I take that 5X and I took one X out, so divided by X, X times 5 gives me 5X, so we're good there. And then X times 3, and then X, we took one of the X's away because it's sitting right here, but we still have 1 left over. Now, 5 and 3, we said were primes. They have nothing in common, and there's not an X in common, so these are our leftovers. These guys on the outside, we're going to multiply together. 1 times X is X, parentheses, leftovers. So that just factored out the GCF. So that's factored GCF. Now, I want you to distribute it back through to check it. So x times 5 is 5x. X times 3x is 3x squared. Is that what we started with? If it is indeed correct, then this is our answer for factoring by GCF. So we factored out the greatest common factor of an x, and our leftovers would be 5 plus 3x. All right, look at this guy. I have a 10 and a 70. So 10, that's 1 times 10, 2 times 5, and that's it. All right, for 70, I've got 1 times 70, 2 times 35. How about 7 times 10? 5 times, you tell me. So what's 70 divided by 5? Because we know that's going to be 1, right? 5 times 14. And I believe that's it. But to find the list of factors, if you go to your calculator, okay, so here's your calculator hack. So you go to your y equals, you type in 70 divided by x, then hit second graph. Your table of all whole numbers are all your factors of 70. So 70 divided by x into your calculator, then second graph, and all those numbers are going to be your factors, the whole numbers. Decimals are not, don't count. So you can't touch decimals. So 1 and 72 and 35, 5 and 14, and we're good. Because after 7, 8 does not go into 70, 9 does not go into 70, and we're back at 10, so it repeats itself. We have all of them. So if I'm looking at my top list and my bottom list, they have 1 in common, but is that the biggest number they both have in common? Nope. Okay, so they both have a 2 in common. Is that the biggest number they both have in common? Nope. So we're done with those guys. Those are out. I got 5 and 5, but is that the biggest? Nope. So that's not our GCF. Our biggest is going to be 10. So looking at this problem, and this is using hockey stick method is the way I like to do it, just because as I've told you before, it's easy to get confused. So 10 times what gives me 10? 1. 10 times what is going to give me a negative 70, 7, and then we got to make sure we have that x there. So looking at that 1 and 7, we now have, again, a set of prime numbers, which means we factored out our GCF. Do they both have a variable? So after we've looked at our numbers, we're good. Next step, is there a variable here? There is not, so that means we're done. We're locked up. So factoring out the GCF, hopefully this is right. So this is the answer we want to be right. We're going to check it. So 10 times 1 is 10. 10 times a negative 7 is a negative 70, and then we have that x. That is what we started with. So indeed, that has factored out our GCF. All right, pause the video. See if you can do this guy. Try the best you can. What does 2 and 10 have in common? And the question you would ask yourself next would be, what variables do they both have in common? So pause your screen and give this your best go. All right, so 2. That means I have 2 times 1, and that's it. For 10, I've got 1 times 10, 2 times 5, and that's it, right? So you got a 1 and a 1 in common, not the biggest, so we're done there. 2 and 2 in common, and that's all we have in common. So it looks like we're going to take out a 2. So 2 times what gives me 2x squared? We have left over 2x squared because we pull the 2 out. And if you want to, we can put a 1 right there just to keep ourselves straight. 2 times 5 gives me 10, and then we have our x left. Now I'm looking at these numbers. 1 and 5 are prime. They have nothing else in common, so we're done with our numbers. All right, we're going to look at variables. So they both have an x. They do both have an x, so we're going to pull 1x out. So you can leave our 1 here. If I take 1x away, where this is actually like having 2 x's, right? It's the same thing as x squared. I take 1 out, I have 1 left. I have 1 here, but I took 1 out, so I have none left. So 1 and 5 are prime. This one is a variable. This one does not. So you're done with your leftovers. These two guys, we just put them together. So 2 times x. And you don't have to put this 1 because ultimately it's imaginary. But hopefully this is our right answer. Let's spoil it. So 2x times 1x is 2x squared. 2x times a negative 5 is a negative 10x. Is that what we started with? Yep. So that means this is indeed factored out the GCF. All right, big mumbo jumbo. So here's where your hockey stick method works wonders. So I have 8, 4, and 12. Okay, so pick a number that you know goes in all of these. Some of you, 2 is going to be the first number you see. So we're going to go with 2. So 2 times what gives me 8? 2 times 4. We haven't dealt with our variables, so we're just going to write those down. 2 times what gives me 4? 2 times 2, right? We're not dealing with our variables yet. 2 times what gives me 12? 2 times 6, right? So 6x to the third, y to the third. Now, you want to look at 4, 2, and 6. Do they have another number in common? 4, 2, and 6 all can be divided by 2, right? So 2 times what gives me 4? 2. Again, we haven't touched our variables yet. 2 times what gives me 2? That's our 1. Haven't touched our variables yet. Haven't gotten there. 2 times what gives me 6? Now, if I look at 2, 1, and 3, so you're looking at 2, 1, and 3. Up here, you're looking at 4, 2, and 6. So it's very obvious to see a 2 is in common. 1 and 3 are prime numbers along with 2. So we know we've taken out all our numbers. So we're good as far as the numbers concerned. The next thing on your list is to look at your variables. So I'm going to look right here. I have an x. Do I have an x all the way through? I do. So I'm going to take out 1 at a time. So 2, and I have 2 x's here, so that leaves me with 1. Y's we're not dealing with yet. 1. I have 5 x's here. I took out 1. That leaves me 4. I have 1 x on the outside. I had 3 here, so now I have 2. We haven't touched our y's yet. So looking down our line, we've already handled our numbers, so we move on. The next thing we should look at is x's again. Do I have another x all the way through? I do. So I'm going to go ahead and pull him out as well. Another x all the way through. So 2, this x is now out here, so there are no x's, so I'm down to y5. I had 4 x's, I pulled 1 out, x to the third. I have 2 x's, I pulled 1 out, I'm down to 1, and then y third falls down. Now, left or right? So I've taken care of my numbers. 2, 1, 3 is good. I don't have any more x's, so we're going to move on to y's. Do I have a y all the way through? I do. So I'm going to pull them out 1 at a time. Some of you may have already seen the pattern. That's going to leave me with 4 y's. We're done with our x's, so we just got to fall down. I got 3 y's. I took 1 out. That's going to leave me with 2. I had 3 y's. I took 1 out. That's going to leave me with 2. So at that rate, now I have to look at it again. And I've got y to the fourth, so I have another y, so I can pull out another y. So that leaves me with 2y to the third plus 1x cubed. I have 2 y's here. I took 1 out, so that leaves me with 1. 3x. I have 2 y's here. I took 1 out. That's going to leave me with 1. So I'm going to look down my line. 2. Oh, there's another y still. Is there a y all the way through? There is. That means I can pull out another y. That's going to leave me 2y squared because I had 3, but I took out 1. So 1x cubed, because we're past our x, so we have 1y. We pulled 1 out, so there's none left. 3x, 1y, pulled 1 out, so there's none left. Now, so that means 2, 1, 3 done numerically. I have a y still left here, but there's not another y left. So you're done. These are your leftovers. So they're definitely your leftovers. So 2y squared plus x cubed plus 3x are our leftovers. Then you're going to look down your line right here and multiply all these together. What's 2 times 2? We have a 4. We have 1, 2, so we have 2 x's. 1, 2, 3. And remember, that's when we add our variables together because, our exponents together because these are like ones. And when we multiply, we add the tops. So our GCF should be 4x squared y cubed. Now, if I multiply this through, 4 times 2 is 8. X squared doesn't change. Y cubed and y squared. So we add, right? We're going to go to this guy. So we're going to just multiply by x cubed. So 4 stays the same. I have 2 x's here, 3 here. So that means I have x to the 5th, y to the 3rd. There's not another one, so it's going to stay the same. One more time. So 4 times 3 is 12. X squared times x is x cubed. Y cubed, nothing changes it. Y cubed is this what we started with. 8x squared y 5th plus 4x to the 5th y 3rd plus 12x cubed, y cubed as well. That is what we started with. So we have factored that problem's GCF here. This is the GCF. This is the leftovers. Now, if you think about it and you look at it and you see they all have an x in common. This had a 5, this had a 3, this had a 2. So ultimately, we're looking at x squared, x to the 5th, and x to the 3rd. What is the lowest exponent here? This guy. So you could get rid of this and turn this into one big hockey stick if you look for the lowest exponent in the sets and pull that out the first time. We'll try that on this one. All right, so first of all, I've got 24, 16, and 40. I'm going to go with 4 and see what happens. So 4 times 6. We're not messing with our variables yet. 4 times 4 gives me 16. 4 times 10 gives me 40. Now, I have 6, 4, and 10. So I'm looking at 6, 4, 10. They definitely have another number in common. All of them can be divided by 2, right? So I'll pull out 2. 6 divided by 2 is 3. 4 divided by 2, or 2 times what gives me 4, is 2. I'm not messing with our variables yet. And 10 divided by 2, or 2 times what gives me 10, is 5. And again, we're going to leave our variables alone. So right now I have 3, 2, and 5. Prime, prime, prime. So we're done. Can't do anything with our numbers. Next down the line is x's. So x to the 5th, x to the 7th, x to the 3rd. So x to the 5th, x to the 7th, x to the 3rd. What is the lowest exponent? I have a 5, a 7, and a 3. So the lowest exponent is going to be 3. So I'm going to go ahead and pull out x to the 3rd power. That's going to give me 3. So if I have 5 x's and I pulled out 3, that means I'm left with 2. Okay, so I have x to the 7. So if I had 7, I pulled out 3, that means I'm left with 4. And then I had 3 and I pulled out 3, that means I'm left with none, and I just have my y squared. Now after that, so we've taken care of our numbers, we've taken care of our x's. Now looking at our y's, I got y squared, y cubed, y squared. So squared, cubed, squared. So 2, 3, 2. And the smallest number would be 2. So I'm going to pull out y squared. So 3x squared falls down. If I had 2 and I pulled out 2, I have none. So 2x to the 4th just falls down because that's left over. If I had 3 and I pulled out 2, I'm left with 1. And then my 5 stays. If I had 2 and I pulled out 2, that leaves me none. It looks like I'm done here. So 3, 2, and 5 are all done. X is here, no x, so I can't pull anything out there. There's not another variable here. There is a y here, but it's not in the last 2, so you're done. So these are our leftovers. And what goes on the outside is this guy multiplied together. It was 4 times 2, 8. These you don't have to multiply together because they're already, we did it by taking the lowest exponent. So 8x cubed y squared. Check it. So 8 times 3 gives me 24. X cubed times x squared is going to give me x to the 5th power. Then I have y squared. Then I'm going to do 8 times 2 plus 16. I have x cubed and x to the 4th, which is 4, 5, 6, 7, right? X to the 7th. Y squared and y. Give me y cubed. And then I'm going to do it one more time. 8 times 5 is going to be 40. X cubed y squared. Does this match where we started? It does indeed. So we have now factored out our GCF. Okay, pause your screen and give it a go. If you have to pull out one by one, if you're using the lowest exponent, you try it. All right, 4, 2, and 12, we'll fill out a 2. 2 times 2 gives me 4. Waiting on our variables, we'll get those in a minute. 2 times 1 gives me 2. 2 times 6 gives me 12. Which means I'm now looking at 2, 1, and 6. 2 and 1 are prime. So there's nothing else that can be divided by besides 2 and 1. Now, 6 can be divided by 2, but 1 cannot be divided by 2. So there's nothing, the 3 numbers, all 3 of them have to have it in common. So there's nothing else that I can pull out. So we're going to move on down the line to our variables. I got x, and I have an 8, a 3, and a 5. What's the lowest exponent? 3, right? So I'm going to pull out x to the 3rd power. So 2 falls down. I have 8 x's right here. If I take out 3, that means I have 5. Okay, my 1 falls down because we moved past that. I have 3 x's here. I took out 3, so that means I have none. So just my y comes down so we can deal with it next. I have 5. I pulled out 3. That means I'm going to be left with 2. Now, so we've got a row. We want to check for x's. There's an x to the 5, not an x here, so we're good as far as x's. Next in line is y. take y, I have 4, 3, and 6. So 4, 3, 6. The lowest exponent is a 3, so we're going to do y to the third power. 2 falls down, x to the fifth falls down, so we've moved past x. I had 4 y's. I took out 3 y's, so I have 1 y left. I have 3 y's. I took out 3 y's. I'm going to leave that 1 by itself. It's a space holder, because remember, if I made this into a nothing right here, then when I distributed through, this 1 wouldn't have a, there has to be a third, or in this case, I guess, second of the 3 terms would have to happen right here. So that 1's going to hang out right there. So we're going to go on to our next guy down. I have 6 y's, so 6x squared just falls down. I had 6 y's, pulled out 3. I have 3 left over. So I have 2, 1, 6. That's the best I could do. X, no x, so we're done. Y, no y, so we're done. So our leftovers, in this case, that 1 is very important. Look out here, and I've got 2x to the third power, y to the third power. So if I multiply this through, 2 times 2 is 4. X cubed times x to the fifth. So 3 plus 5 is 8. Y to the third, y to the 1. Because remember, if there's nothing, there's a 1. So 3 and 1 is 4. Go to our next guy. So that's going to be plus 2x cubed y cubed, because that's the same thing. It times 1 is itself. 2 times 6 is 12. X to the third, x to the second gives me x to the fifth, because we add 3 and 2. Y to the third times y to the third is y to the sixth, so we add them together. Is this where we started? 4x to the eighth, y to the fourth, plus 2x to the third power, y to the third power, plus 12x to the fifth power, y to the sixth power. It is, so in that case, this indeed is our answer. This is our GCF, and these are our leftovers. All right, last but not least, try it. Pause your screen, get after it. Pulling out a 6. So that's going to leave me with 1a cubed b squared. 2 times 6, or negative 2 times 6 gives me that negative 12. 6 times 3 gives me 18. And I have 1, 2, 3. There's no number that all 3 of them would have in common, so we're done with our numbers. So after we take care of our numbers, that's 1, 2, 3, we're done there. The next thing in line is an a. I have a to the third power, to the second power, and to the 1 power. So the smallest number, because remember, there's no number, that's a 1. We're going to pull out 1a, because that's the smallest exponent. So when I take away that 1, so I have 1, it falls down. If I have 3, I take 1 out, I have a squared, b squared. If I had 2 and I take 1 out, I have a. I have 1, I take 1 out, I have none, so b is by itself. A is still here. A is still here. No a, so we're done with our a's. All right, looking at our b's, I have b squared, b to the third power, and b to the 1 power. So that means the lowest is just b to the 1 power, so that's what we're going to pull out first. So 1, a squared. I have 2 b's here. I pulled 1 out. I have 1 left. All of this falls down because we've already done it. So b to the third power, I pull 1 out. I have b squared. B to the 1, b to the 1, no b left. So 1, 2, 3, we know is prime. A, no a, so we're done with our a's. B, b, no b, so we're done with our b's. So this is our GCF. Our leftovers are 1a squared b minus 2ab squared plus 3. Now to check it, 6ab times ab squared, a squared b, I'm sorry. So 6 times 1 is going to give me 6. This is imaginary 1, imaginary 1. So 1 and 2 is going to give me 3. b1, b1 is going to be b2. Looks like our first guy. Good. Do it again. So 6 times a negative 2 is a negative 12. 1 and 1 gives me a squared. 1 and 2 gives me b cubed. 6 times 3 is 18. ab. Is this what we started with up here? It is indeed. So this is our polynomial factored by GCF. So this is our GCF, and these are our leftovers. All right, this is going to look like what you're going to need in the next couple of days. All right, so this is much closer to what you're actually going to be using and actioning. You do need to understand these, because they can happen, but these are the ones you're going to run into the most. So pause your screen, try it. And I'm going to pull out a 3. Gives me x cubed plus 4x squared plus 3x. So number-wise, that means 1, 4, 3. 1, 4, 3. 3 and 1 are prime. 1, 4, and 3. The only thing they all have in common would be a 1. So we're done numerically. Next thing in line is an x. So we can put an x. Needs to have x squared plus 4x plus 3. So if I had 3, take 1 out, I get 2. If I had 2, take 1 out, I have 1. If I have 1, take 1 out, I have none. So x, x, no x's. So we're done. So this is definitely our GCF. And this is our leftovers. Distribute it to check it. That's going to be 3x cubed plus 12x squared plus 9x. Is that where we started? It is indeed. So this is our answer. So this is just us checking our what we think is our GCF and our leftovers. And this is the answer to the question. If it says factor by GCF. So this is when the question says factor by GCF. If it says what is the GCF, this is our GCF. This is the whole thing when factored by GCF. All right, try again. So I'm going to pull out a 5. 5 times 6 gives me 30. 5 times 5 gives me 25. 5 times 3 gives me 15. 6, 5, and 3. So I'm looking at 6, 5, and 3. If I had 3 and 6, I could pull out some more. That 5 messes us up, so we're good. There's nothing that all 3 of them have in common other than 1. Next thing in line is an x. There's an x, but there's not an x here. So that means there is not an x in common all the way through. Ultimately, they usually are going to be in standard form. So highest exponent to last exponent. So if they are indeed in standard form, like we learned last week, so in this case, like 4, 1, none, right? Then if there's not a variable out here, you can stop. There's no reason to even look at them because this x, to be able to pull it out, has to exist in every term in our list or in our polynomial at this point. That means we have a factor of 5 and our leftovers are here. So again, this is our GCF. This is factored by GCF. So we're going to check it. 5 times 6 is 30, x to the 4th. 5 times 5 is 25x. 5 times 3 is 15. Is that where we started? It is indeed. So this is the answer to our question. This is us just checking to make sure. This is the answer as far as factored by GCF. All right, pause it. Try it. Hope you're writing these down. Don't want to mess up. Pay attention to this negative right here. That matters. You want to get that negative out when you can. You definitely do not, when in standard form, want to start with a negative. All right, so I'm going to pull out a negative 5 to get rid of that negative in the front. So negative 5 times 7 will give you negative 35 m squared. Negative 5 times a negative 6 gives me positive 30. So you can put plus or you can put plus a negative. And negative 5 times a negative 3 gives me a positive 15. So you can do plus a negative or you can just do minus. So my numbers, I now have 7, 6, and 3. None of those have anything in common. These two guys, if they're by themselves, we could pull out some more. We could pull out another 3. But that 7 messes us up. So we're done as far as numbers are concerned. We're going to look for our letters, m squared, m1, m none. There's no m out here. So that means we don't have a GCF of an m. So the only GCF we have is at negative 5, which we could write this way, or we could write it this way. Now check it. So this, we're hoping this is the correct, correct answer. So this is hopefully our factored by GCF with that negative 5 in the front. So check it. Negative 5 times 7 is negative 35 m squared. Negative 5 times a negative 6 is positive 30m. Negative 5 times a negative 15 is a positive 15. Is that where we started? It is indeed. So again, this is factored by GCF. This is us checking to make sure we did it right, because that's what we basically did last week, is you're working on distributive property and multiplying binomials, polynomials, and monomials. So it's making sure that you can factor by GCF and then indeed prove that that is correct. So this is factored, and the GCF itself is -5.